Okay, let's start doing the inverter schematic. So now we'll see how we are going to create an inverter schematic using the Cadence tool. First we need to run commands shown here, that is csh source cshRC, and we need to enter into the Cadence MSLab 614 by entering this command cd, that is change directory to the MSLab 614, and after that our virtuous. Okay, virtuous is a command to launch the Cadence license. So okay, after that just minimize it, you will get this window. So after that go to file, and first you need to create a library. So go to new library, and in the library you have to give your library name. It should start with the alphabets, and spaces are not allowed. So I will give ATEMECE is my library name. Click on attach to the existing technology library button. So click OK, and here you have to select the GPDK 180, that is generic process design kit 180, the technology which we are using. So next we need to create a cell view. So new cell view under the same library, that is ATMRCE is my library. So just select this library, and the cell name, that is the cell view name, give your own name, cell view. Okay, I am giving as it as INV. So after that, so now we need to create a schematic of an inverter. For that, go to create instance, browse, and select the library GPDK 180. We need a Cmos. Okay, just click on it, close, hide, place the Cmos here. Once again go to the create instance, so browse, we need Nmos, just type here Nmos, I'll get this Nmos. Okay, no need to change any parameters for this experiment, it's not required. So that's why I'm not changing any of the length or width of this transistor. So next we need a pins for connecting this. So for the pin, create pin or shortcut P. So in this P we need a VDD and VSS and VIN. So we need these three pins as an input. So create direction as an input. So click on hide. So VDD, VSS and VIN, and go to same create pin, and now we create Vout, OUT, and make the direction as output and place it here. So after that click on escape. So next we need to join these things according to our schematic diagram or a circuit diagram which we have. Okay, for that click on the wire, narrow wire, just click here and place, click on this yellow box and just place. So do this according to the circuit diagram. So just short these things. Okay, next click on check and save. If there will be any error or the wires are not connected properly, it will show an error. So it's connected properly, so we didn't get any errors here. So after that we'll proceed it to the next step, that is the making test bench of this inverter schematic. So for that just create, go to file, new, and here once we check it's the same library that belongs to you. So after that we need to change a small modification, that is inverter underscore TB. So this will be done for our recognition, so that it's a TB file, that is test bench file of this inverter schematic. Click on OK. So after that, so before you will get this window, after creating this schematic, one more thing we need to do is just create a symbol of this schematic so that it can be used in the test bench. So create cell view from cell view, click OK and rearrange the pins as in the circuit diagram of the test bench diagram of your inverter. So just cut it and paste it. It's a bottom pin and VDD is the top pin. Okay, click on OK and click on check and save and close it. So it's enough. After that, go to the test bench here. So in the test bench, once again create instance, browse, go to your library here, because the symbol is saved in your library, because the schematic is in your library, that's why. Okay, now we'll get the symbol of the inverter, and for that we need some sources. So for that, also create instance, go to browse, and here we go to the library, that is analog library. Click on analog library and type here the source name vpulse, PULSE, vpulse. Click on the symbol. Okay, place it here. So we need to change parameters, some parameters of this according to the given constraints. So v1 is equal to 0 and v2 is equal to 1.8. so it is our given constraint, and the period, that is equal to 20 nanoseconds, 20 nano, 1.8 volts, and 20 nano. Period is a T on and T off time. T on plus T off is equal to a period. Okay, click OK. The parameters are changed, you can observe. Then next, go to create and just type here VDC, because it's already in the same library. So just type the DC voltage for the VDC. A DC voltage for a VDC is 1.8. once again. So click on hide and place it here. For rotating this, just right click and place it here. Next, we need some ground points for grounding. That also create instance, go to and type GND, ground. Hide, you will get the ground pin here. So place it wherever you need. After that, we need one pin for the output, that is Vout, out. Once again, check the direction, it's output only. So click on hide and place it here. After that, join these things with a narrow wire. Create narrow wire. Let's see the simulation part of this test bench. So for the simulation, go to launch and click on ADEL, launch ADEL. You will get this window, and go to analysis, choose analysis. First, here we are going to analyze two things. There is a transient analysis and a DC analysis. So for transient, just give 200 nanosecond time. So apply it, and for DC, click on DC, click on save DC operating point, select component parameter and select component, and select the vpulse. Just double click on this VDC, go to the choosing analysis, and for DC we need to start and stop voltage of that. So 0 to 1.8 volts we are varying the DC voltage, so that's why. Click on apply and OK. And after that, here is a button called setup outputs, or go to the outputs and setup outputs. All are the same, so it will be easy. So click on from schematic, just select the input and output pins. For that, click on the run button here, run simulation. Click on this button, you will get the transient and DC response of the inverter. So this is the transient response of the inverter, this is the DC response of the inverter. So after that, close it. So in the next video we are going to know how to create